Okay, so what we have here is a 3 by 3 system of equations that we need to solve. We need to find x, y, and z. And the first thing I'm noticing is that the twos are smaller than the numbers I have in the first equation. And so what I want to do with that then, and this is one of the things that we're allowed to do, is to change the order. So I'm going to put this equation first just because I feel like it might make some of the computations easier. As it is, there's quite a bit of opportunity for error. Now, you also want to make sure that you copy that correctly because it's really easy to lose a sign or change a number. Uh, so, you know, transposing numbers is also a very common kind of human error. And so we want to see if we can avoid those. I just left that one where it was. Um, I don't think that at this point is that important. And then the last one we'll just put on the bottom. So they're just swapping positions. I could have changed the order altogether. Does anybody have any questions so far? And I'm happy to stop the recording if we do. Anybody have any questions?
No.
Thank you. All right. All right. So it's always helpful to have your eyes on what I'm doing, checking me, making sure that I copy things correctly. So if you see something, please let me know. But it looks correct so far. All right. So again, my next goal is actually going to be to uh, eliminate this term and this term. Okay, so to do that, that's going to require some special work here. And typically this stays as is. It's not something that we are going to do anything with. But to get the next line, what I'm going to do is, we usually call this equation 1, this equation 2, and this equation 3. And forgive me, the interface between my pen and the screen isn't perfect. But that's a 1, a 2, and a 3. All right, I'm going to take equation 1, multiply it by negative 2. That's a negative 2. And add it to equation 2. Okay, so that's a negative 2. That doesn't come out very well, my screen. But here's what we do. So negative 2 times negative 2 is positive 4, plus negative 4 is 0. Now, I can temporarily put a 0x, but I don't necessarily need to write it, okay? Then it's going to be, but that was the idea, is that that becomes a 0. So now I'm at negative 2 times 2 is negative 2, negative 4, minus 2 is minus 6. Negative 2 times negative 1 is positive 3 minus 2 minus 1 is 2. Oops. I have to work with a 28, so that's not a 0. Negative 2 times 6 is negative 12 plus 2 is negative 10. Okay. We're going to do the same kind of thing with a third equation, but it's a little trickier. It's a little trickier, so let me think about this for a second. Let's do this. Let's copy it for now as is. We do want to get rid of that negative 3x, but I feel like we could improve things, and if I do the following, okay, I'm gonna leave the third equation as is for now, the second equation as is, but the first one, I am gonna divide it by negative 2, which is the same as multiplying by negative a half. So dividing this by negative 2 is a 1x. Dividing a 2 by negative 2 is a negative y. Dividing negative z by negative 2 is positive 1/2 z. Now that's not a really easy to work with number, but it's helpful to have ones here. And then 6 divided by negative 2 is negative 3. Okay, and then I've got negative 6y plus 2z is equal to negative 10. Now, if somebody needs me to explain, please say, raise your hand, or say, can you pause the video for a second? I'm keeping this equation as is as well, right? It's an equal sign, so this should be equal 0. All right. I'm leaving this alone. After the division by the negative 2, that's what we get. This one, I'm fine with it the way it is because we're trying to get it into upper triangular form. Now, what I'm going to do on the third one is I am going to take the first one and multiply it by 3 and add it to equation 3. Okay, so 1 times 3 is 3, plus negative 3 is 0. Now, I'm just going to put a 0x just for a minute. I am going to erase it very soon here. Now, negative 1 times 3 is negative 3, plus 9 is plus 6. This one gets a little tricky because it's half of 3, which is 1.5 minus 6 is minus 4.5. And then negative 3 times 3 is negative 9 plus 0 is negative 9. Okay, does anybody have any questions? See any mistakes? Okay, let's go ahead and continue. And actually, before I continue, let me identify a couple of mistakes that I just noticed. And it's as follows. I believe there's a mistake uh, in this equation here. So it was in the computation. So it would have been negative 2 times negative 2, which is positive 4 plus negative 4 is 0. So that's okay. Negative 2 times positive 2 is negative 4 minus 2 is minus 6. So no problems with that. But negative 2 times negative 1 is positive 2. When you take away 1, this should be a 1. And the negative 2 times 6 is negative 12 plus 28 is 16. Negative 2 times 6 is negative 12 plus 28 is 16. So that changes this, 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 and this. So that's 116, 116, and it's a positive 16. Okay, now we can leave this equation as is. 1x minus 1y plus 1 half z is equal to negative 3. We leave the second equation as is, now that we fixed it. And what we're going to do is we're going to add equation 2 and 3. And we're going to get a new equation because the 6's are going to cancel. And we've got 1z minus 4.5z, that's minus 3.5z. And then 16 take away 9 is 7. 16 take away 9 is 7. And then you can begin to back substitute. Let me make this a little smaller so I can do the back substitution. And we're real close to the end of this problem. Okay, so negative 3.5z is equal to 7. That means z is 2. Okay. Then let's go to the second line. Negative 6y plus z is equal to 16, but we already know z is 2, right? So let me erase the z, and instead I'm going to put a 2. So negative 6y is equal to 14 divide by negative 6 divide by negative 6. So y is equal to I'm getting negative 7/3. Whenever I get something that's not a whole number, it always causes me to think about whether I've uh, made an error somewhere. But, and I think I have actually, this should have been a negative. This should have been a negative, which would have made this 18, which then you're not guaranteed nice numbers to work with, but often they are easy numbers to work with. So just kind of keep that in mind. And then there you go. So now we've got, we use the very first equation, and I'm happy to use, I can use this one. So x minus y plus half of z is equal to negative 3. That means x plus 3 minus 1 is equal to negative 3. X plus 2 is equal to negative 3. So x is negative 5. So you have your 3 coordinates that make up the solution. If you're careful, it is a long problem, but if you're careful to check each step, you will find the answer.